Solve tan x minus 3 sin x equal to 0 for 0 degrees less or equal to x less or equal to 720 degrees. Give answers to one decimal place. Tan x minus 3 sin x equal to 0. But we know that tan x equals sin x over cos of x. I'm going to replace tan x with sin x over cos x. Sin x over cos x minus 3 sin x equal to 0. This is over 1. I need to make this the same denominator. So I need to multiply that by cos x and that by cos x. Sin x over cos x minus 3 sin x cos x over cos x equal to 0. And now what I need to do is multiply both sides by cos of x so that I can eliminate the denominator. So if I times this by cos x, I need to times that by cos x. Cos x cancel cos x, cos x cancel cos x, and I also times that by cos of x, and that's 0. Sin x minus 3 sin x cos x equal to 0. And the common factor is sin x. So what I need to do then is take sin x out. Sin x 1 minus 3 cos x equal to 0. Sin x times 1 is sin x. Sin x times minus 3 cos x is minus 3 sin x cos x. Now what I need to do is set sin x equal to 0 and set 1 minus 3 cos x to 0. Sin x equal to 0. Divide both sides by sin. X equals 1 over sin times 0. Therefore, in indices, 1 over sin is sine to power minus 1, which we call inverse sine of 0 equals x. Now, then the next one to set to 0 will be 1 minus 3 cos x equal to 0. Take minus 3 cos x to the other side, so I get 3 cos x equals 1. Cos of x equals 1/3, and x will be 1 over cos 1/3. And then in indices, 1 over cos is cos to the power minus 1, 1/3. So look at the x equals inverse sine. That's inverse sine. Inverse sine of 0. So all I need to do is actually draw a sine function. So I'm going to do that now. And this is y equals sine of x, and that is x. So if I start from 0, sine of 0 is 0. That's 2 pi. Go another cycle because we need to go 0 degrees to 720 degrees. So go another one there. So this is 0, that's pi, 2 pi, 3 pi, 4 pi. So that's 180 degrees, 360 degrees, 540 degrees, 720 degrees, just like that. Now, the top here the amplitude is +1 and -1. But I'm looking for 0. 0 there, 0 there. That means when y equal to 0, you can see sine x equal to 0. So y is 0. So y is 0 at those points here. So that's the solution for this one. And the solution for this one is x equal to 0 degrees, 180 degrees, 360 degrees, 540 degrees, and 720 degrees. So that's the solution for that. Now I need to find the solution for the second one here. In that case, all I need to do is to bring in a calculator, put the calculator here, and I need to find the x value. So turn on the calculator, shift cos, that will give us the inverse cos. We need a fraction, so fraction key, 1, bring that down to 3, close the bracket, 70 points, so x is 70.5 degrees because we have to give it to 1 decimal place. So that's 70.5 degrees. But I need to find the rest of the value for x. In order to do that, I'll use a cast diagram. So with a cast diagram, I'm using a circle, unit circle cast diagram. Along the x-axis is what we call the cos of x. And along the y-axis is the sine of x. We're only interested in cos of x. But because I'm using a unit circle, so from there to there is 1. And therefore I need 1/3. Cos of x is 1/3. So that means 1/3 will be somewhere here. So if I trace it up, if I draw a unit circle with that, so it's just, if I just draw a unit circle, just let's say draw a unit circle. There we go. And the 1/3 will be up here. So if I trace that up, so it will be there, and that will be the angle that we're looking at here, 70 degrees. That's when, so you go. So that's 70 degrees, 0 to 70 degrees, 70.5 degrees. And the other angle will also be, if I extend that down to that point there, and that will be that other angle here. So I need to go from 0 to 70.5 because this is 0 degrees, and then back to 360 degrees. And then the second point will be all the way to here. So remember, this is 1/3 here. And so that's all the way back to here. And back to here is actually 70 degrees because I'm going from 0 all the way to here. So that would be 70.5 short of 360 degrees. So that would be, if this was 70.5 degrees, this would be 289.5 degrees. So that means 360 minus 70.5, because this is 70.5 as well. It's minus 70.5 here. And then I need to go to 720. So that means I need to start again from 360 all the way to 720. So that would go to 720 degrees. So to do that, I then need to start again from 360 plus 70.5. 360 plus 70.5 should give 430.5 degrees. So that's the second round of the journey, 360. There you go. And then the other one is 360 to that. So that would be second round. And that would be, again, so you just add 360 to 289.5 degrees. And that should give 649.5 degrees. And those are my values that I'm looking for. This is the second round. And that's 360 to 720. And the first round is this one here. So those are my x value for this, for the cos. And the x values are, so for the cos, it will be x degrees will be equal to, sorry, x will be equal to 70.5 degrees. And then 289.5 degrees. And then 430.5 degrees. And then 649.5 degrees. Now the whole of the answer will then be combining these and that for the two functions we've got. So the x will then be equal to 0 degrees, 70.5 degrees, 180 degrees, 289.5 degrees, 360 degrees, 430.5 degrees, 540 degrees, 649.5 degrees, and 720 degrees. And those are the values of x that satisfy the equation that we're to solve for that intervals. That means for that boundary between 0 degrees and 720 degrees.